Here at the top. So I just have a triangle, right? ABC. So angles, just in general, when you label an angle, use capital letters. Angles use capital letters. There's no other way I'm going to label an angle other than capital letters. Now, what you guys are used to for sides, and I'm going to just show you a new method in 1 second, but just in general, sides in a triangle, we use the endpoints of each of the line segments, right? So AB is one of the sides, BC is one of the sides, and CA, kind of wrote that too big. Those are each of the sides in the triangle, just how I would typically label it. So I'm just going to give you another method. What you can also use to label the sides in a triangle is you're going to use a single, instead of the endpoints, we're going to use a single lowercase letter, and it's going to be the same as the angle the side is opposite or across from. Okay, so, and I'll draw it in the picture here in a second. So you can use a single lowercase letter, and it will be the same as the angle the side is opposite. And I'll just label it in this picture here real quick. So if I have angle B, capital letter, if I go across the triangle or opposite the triangle from that angle, I can call the side across from that with just a single letter. I can call that side B. If you have angle C, I got that over here, capital letter, the side across from that or opposite that, you are allowed to label that side C, just a single lowercase letter. And then finally, angle A, capital letter, the side across from that, I can label that with an A. So if you just want to use a single letter, let me write them next to my line segments. So side AB is really C because it's across from that angle. BC is going to be side A, and CA or AC would be side B. So that's across from that. Those are all lowercase letters. If you want to use the endpoints of the line segment, they'll be uppercase letters because those are labeling the angles. But all of those methods are totally fine. So if you want to use lowercase letters, that's fine. If you want to use line segments, that's fine. I kind of have them both mixed around in the notes a little bit today. Okay, so the first thing we're going to talk about is how you can, without knowing any numbers or anything like that necessarily for angle measures, how can you determine which angle is bigger than any other in a diagram of a triangle? So this says if two sides of a triangle are not congruent, so as long as the sides are different, the larger angle is going to be opposite the longer side. Okay, so if you have two sides in a triangle, if they're congruent, the two angles would be equal that are across from two sides that are the same. So that's why it says not congruent. The larger angle is going to be opposite, or if you want to write opposite means across from the longer side. So whichever side is longer, that angle across from that is going to be a bigger angle. So in the diagram here, let me just practice that one more time, labeling with the lowercase letters. So if this is angle Y, this would be side Y, lowercase letter. If this is angle Z, across from that would be side Z. If this is angle X, this would be side X. So in the question, or not in the question, in the description right underneath there, this just says if Y is greater than Z. So if that segment is longer for the segment to Y than Z, then angle Y is going to be bigger than angle Z. That's what that says. We're just going to actually do this down here in a problem. So this says, and pay attention to these when you're doing these questions, because sometimes it says largest to smallest, sometimes it says smallest to largest. So make sure you read the question. This says list the angles of the triangle in order from smallest to largest. So if I want the smallest angle, it's going to be across from the shortest side. So here's my triangle, right? My sides are 5, 12, and 13. What angle would be the smallest angle in that diagram? C, right? That's it. So shortest side is 5, the smallest angle is across from that, so angle C. Which angle would you list next? So like in the middle. angle B. So 12 is bigger than 5 but smaller than 13, so angle B is going to be in the middle. And then 13, that's the longest side, so the biggest angle has to be across from that. That's going to be angle A. That's all you have to do. Okay, second question here, same problem, but I'm going to not give you a diagram. So I'm going to suggest if you don't have a diagram, maybe try to sketch yourself one. So not drawn to scale, this is just to help give us a reference. So this says I have triangle RGY. So I'm just going to label capital letters there. And then it says the sides. Now these are lowercase letters. So side Y is going to be across from angle Y. So this would be a lowercase y, and that side would be 14. This is not to scale at all. I'm just sketching this picture as a reference. Side R, it's lowercase, is 12. So that's going to be across from angle R. And the side G is 20. So G would be over here, and that's supposed to be 20. Again, as you guys can see, that my diagram is no problem. Definitely not to scale. Okay, now make sure you read the directions on these because they switch them up. This one says I want to list these angles from largest to smallest. Which angle in that diagram, again, my diagram is not to scale, so just look at the side lengths. What angle would be the largest? Bryn, what do you think? G. All right, so angle G there. What one would be in the middle? Y. Yep. And then the biggest side is 20, so that's got to be the biggest, the smallest side is R, so that's got to be the smallest angle backwards. But that's all you have to do. Is anybody having a question? Okay, very similar theorem, but I'm going to kind of flip the script, and this is going to say list the sides in order based on the angles. So this says if two angles of a triangle are not congruent again. If you have congruent angles, the sides across from them are going to be the same length. So that's why it says not congruent. This is going to say the longer side lies opposite the larger angle. This is very similar. We're just going to do sides instead of angles here. So the longer side is going to be across from the larger angle. So opposite. So this means if the measure of angle A, and if you want to look at the diagram, this would go with the diagram. So if I look at angle A, so here's angle A. If the measure of that angle is bigger than, and hopefully you guys can tell that's a bigger angle in that diagram, than angle B, then it means side A, let me just label it, this would be side A, this would be side B, this would be side C if we use that single letter there. What this is saying is if angle A is a bigger angle measure, then this side A is going to be bigger than side B. It's a little bit easier to do when we actually have numbers in the diagram, so we'll do that on the back. So I'm going to give you some angles, and you're going to tell me the sides. Okay, so first one, I don't have a picture, and you really, honestly, you don't have to draw something for this. Oops, but I'm going to. So it says I have triangle ABC, and C is a right angle. So I'm just going to try and sketch a little right triangle so you guys can look at it here. And I just tried my best to do a vertical line and a horizontal line. That would make a right angle. And that's supposed to be angle C. Now, it doesn't matter. I'm just going to label the other two vertices A and B. You could switch that up if you wanted to. It wouldn't matter. So side A here would be across from angle A. Side B would be across from angle B. Side C would be across from angle C. If I have angle C as a right angle, this one just says, just tell me what the longest side in the triangle would be. I don't know the other two angles. I just know angle C is a right angle. What side in the triangle would have to be the longest? Let me know. Okay, why? Could I have a bigger angle than 90? No. Okay, see if this makes sense to you guys. You know the inside angles of a triangle add up to 180, right? If I have a 90-degree angle, I couldn't have like a 91-degree angle because that would add up to more than 180. So if you have a 90-degree angle, that has to be the biggest angle in the triangle. So that side C has to be the longest side because the 90 degrees has to be the biggest angle. If you guys want to write, like I wrote C, Or if you want to write the line segment as AB, that's totally fine, or BA if you want to switch that up. But yeah, because that's a right angle, that's got to be the longest side. Okay, now, not a right triangle here. The one underneath, triangle XYZ, has two angles marked in it, and it wants us to write the sides from shortest to longest. So first thing I probably would recommend here, could we figure out that third angle so then we could compare all of them? It's 80. How'd you get 80? Perfect. Okay. You know the inside angles of a triangle add up to 180. If you take the 60 and the 40 together, that adds up to 100. So that other angle has to be the leftover, which would be 80 degrees. Okay, now, shortest side should be across from the smallest angle. All right, now if you want to use line segments, or if you want to use the lowercase letters, this side would be Y, this would be Z, and this would be X. So whichever way you want to do it. What would you tell me the shortest side in that triangle would have to be if I know those angle measures? Y. All right. Which one would be in the middle? Z. And then X is across from the 80. The 80 is the biggest angle, so X has to be the longest side. Now, if you don't like that, if you want to do line segments, that is completely fine. Y would be XZ, Z would be XY, and X would be ZY. So either way, whichever you're more comfortable with is fine with me. I just got to show you both. Does anybody have a question? Okay. Let me scooch this up. I have one more quick theorem for you. All right, so this has just got a triangle. There's no angles marked at all. They just labeled each of the sides with a single lowercase letter. This says the sum of the lengths of any two sides. So if I have a sum, that means I'm adding something. Sum is adding. Any two sides of a triangle, if I add them together, it's got to be greater than the blank. And in the blank, I'm going to put the third side. If you take any two sides in a triangle, if you add them together, it has to be strictly greater than, not equal to, strictly greater than the third side. Otherwise, those segments could not form a triangle. All right, so there's three little inequalities I'm going to write down. You basically just put together every possible combination of two sides that you could add together. So just, it doesn't matter the order. I'm just going to say, okay, if I add the two sides I have marked A and B, what this is saying is that has to be greater than the third side, whatever that would add up to, has to be greater than the length of side C. And I'm just going to write down, there's three possible ways to do this. So if I pick a set of different sides, if I do B and C, if I add those together, that has to be greater than the third side. If I set it up like that, that would be A. And then I could do one more. So let's see what I haven't added C and A. If I take side C and side A, add those guys up, that has to be greater than the third side. In that scenario, it would be side B. So the questions that go with this are going to be like what I have in example 3 here. And it's going to say, are these possible lengths of sides in a triangle? So you're just going to grab two numbers out of the list, add them up, and see if it's bigger than the third number. But you would have to test three things. So I'm just going to take the first two. So if I do 8 and 3, if I add 8 and 3, is that bigger than 4? For sure, 8 by itself is bigger than 4. All right, if I add, let's say, what's the problem?
You can't add 3 to 4 and it won't work.
Exactly. Okay, if I wrote 4 and 8 first, those are both bigger than 3, so that's true, but he's exactly right. If you take 3 and 4, that's 7, that is not bigger than 8. So it has to work for all three. Any one of them, if you would tell me the answer is no, which that would be that combination there. If I did 3 and 4, that's not bigger than 8. Bless you. That is not a possible set of sides that could make a triangle. So it's any possible combination, add them together, has to be bigger than the third side. If any one of them, you would tell me no, that inequality is not true, then not a possible triangle. All right, if I do the one right next to it, I'm just going to do, if I take 8 and 15, if I add those up, the third number they list there is 12. 15 is bigger than 12 on its own, so that I know that works. If I take like 8 and 12, that would add up to 20. That has to be bigger than the third side, which is 15. 20 is bigger than 15, so we're good. And the only other possible combination would be to add the 12 and the 15, and both of those numbers on their own are bigger than 8. So that works for all three sets of possible combinations. So this example is a possible set of sides that could make a triangle. Is anybody having a question? The other little example that's going to relate to this is right underneath here. Now, I'm going to give you two sides for a triangle, and you're going to tell me what could the possible third side be. Now, it won't be a specific number. It's going to be an inequality that'll represent possible lengths, so it's more than one number here. What you're going to do, it's just, I have HF, and then they're calling the side G, and we don't know that. So any two that I add together, so they give me 9 and 17. So if I add those together, I know that has to be bigger than side G, right? And I can just add those. 9 and 17 is going to give me 26. So side G has to be smaller than 26. And let's see what else I could do. We could do like the 9 and the G. That would be two sides. Has to be bigger than the third side, which is 17. Now, for this inequality, I could actually just solve that real quick. I would have to subtract 9, so it's a little bit different than what we just looked at because I just added those together. This is going to give me 8. Okay, so side has to be smaller than 26, but then this is saying it's bigger than 8. Okay, now I'm going to write the third one here real quick, but you'll see this one's not going to make sense. The other possible combination I could get there, one of the sides was 17G. That has to be greater than the third side, which was 9. If you actually solve this inequality here real quick, we'd subtract 17, and this would be G has to be greater than -8. You can't have a negative length for a triangle. So we're not even going to use this one. If you set all three of these up, one of them will give you a negative number, so you don't want to use that. I'm just going to use those first two. They both give me positive numbers. And I'm going to show you a quick way to write this as one inequality. Okay, so that says the side is bigger than 8 but smaller than 26. I'm going to put that G, where's my marker here? Okay, I'm going to put G in the middle. I'm going to put the smaller number on the left, which is 8. I'm going to put the bigger number on the right, which is 26. And I'm not flipping inequality symbols, I'm just moving this around so it'll be in proper notation. So the G is greater than 8, the little part points toward the 8, so I'm going to still point it the same direction. In the other inequality we got, G was less than 26, so the little part pointed toward G. If you write a compound inequality like I just did there, smaller number goes to the left, bigger number goes to the right. Both inequality symbols point that direction if it's right in proper notation, if it's written that way. So this is saying that third side could be any number in that range there in between. It's got to be bigger than 8 but smaller than 26. So like it could be 10, it could be 11, it could be 12, it could be 15.5. Any number in between those two values, not including those two values, would be a possible third side. Okay, could anybody tell me, just looking at what we did there, if I tell you two sides in a triangle are 3 and 12, is there a faster way that you might do that instead of writing out those inequalities from what we did there? Like what could I do with these two numbers to figure out what the possible lengths of the third side would be? I'm saying two sides are 3 and 12. What would the possible third side length be? Could you do it in maybe a different way than writing out those inequalities? Like how can I get the, how did I get the 8 and the 26? How could I get that without setting up a bunch of inequalities? You think? That's it. That's all we ended up doing, right? We added the two numbers here. That gave us the upper end. This situation, we subtracted the two numbers. That gave us the lower end. So you could just do that real quick. So if they give you two sides for a possible length in the triangle, I didn't put letters here, so I'm just going to put, I'm going to put third side in the middle. Okay, two inequality symbols. I'm going to put the smaller number on the left, the larger number on the right. To get the smaller number, you're just going to add the two sides they give you, or sorry, to get the larger number, you're going to add the two sides. So 3 and 12, give me 15. That goes on the upper end. And then to get the smaller number, you're just going to subtract. Now, if I subtract, we don't want to do 3 minus 12 because that would give us a negative, and that wouldn't make sense. We can't have a negative length. So when you're going to subtract, take the bigger number they give you and subtract the smaller number they give you. So I would do 12 minus 3, that would be 9, and that would be on the lower end of my inequality. So any value between 9 and 15, so like 10, 11, 13.5, any of those would be possible side lengths for a third side in a triangle if one of the sides was 3 and the other side was 12. So just add them up, that gets the bigger number, subtract them, don't get a negative, that gives you the smaller number. Okay, now I have one last question. This relates back to a little bit more what we were doing at the beginning of the period. And the question just says literally like, what's the shortest side in this triangle, or in this figure is what it says. And I'm just going to color 2 triangles here to kind of walk you through this a little bit. If I'm trying to find the shortest side, that would be opposite the smallest angle in the triangle. This is tricky though because I have a couple different triangles going on in this problem. So first thing I might do just real quick, let me figure out what the missing angles that I don't have, right? So if I had 180, if I look at my little triangle I colored yellow, subtract 95, subtract 40. Can anybody tell me what this angle here would be? And I don't have my calculator, so somebody please do that for me. What'd you get? 43. 43. It's got to be something different. 45. Okay, I just knew that wasn't going to give me a 0, so 45. So super close. So right here, this would be 45. Okay, now there's 2 ways you could get the angle in this green triangle that you don't have. You could use the 48 and the 47, subtract those from 180, or little major throwback here. This line here is just going to be 180, so you got a linear pair with the 95. So you could just do 180 minus 95 if you wanted to do that, and that would give me the missing angle here. Can anybody tell me what that one would be? 85. Okay. So if I'm trying to find the shortest side in this diagram, first thing I would do is say, okay, where is the absolute smallest angle? Because the smallest angle, that shortest side should be across from the smallest angle. What angle in that diagram is the smallest angle? Z. Okay, so Z would indicate this side right here. That is the shortest side in that yellow triangle, which would be YWZ. Okay, now, is that the shortest side in the diagram? And what I would tell you there, I'm going to look at this green triangle now, is YW, is that the shortest side in that triangle? No, it's not. So what's the shortest side in that green triangle? Exactly. This is very tricky. Okay, so WY, that's the shortest side in this triangle. But if I go over to the green triangle here, that is opposite 48, and that actually has a smaller angle in that triangle, which is 47. So overall in the diagram, XY here would be the shortest side in the entire figure. All right, so that's a tricky question because we're using 2 different triangles. But I would always tell you, if you're trying to find the small side, find the smallest angle, and then like we just check that side. So this was the smallest side in this triangle, but it's not the smallest side in the other triangle that I colored green. So XY would be the smallest side overall in that diagram. Is anybody having a question?